So this is what we discussed so far. WinForm application which you see, WinForm application is going to have ultimately all C# code generated. Partially it is going to be auto written and partially developer writes it. Ultimately partial classes are going to get clubbed as single class only, and that single class in C# is going to get compiled as MSIL, and MSIL is going to be one part of your .NET assembly, which we saw some time back. However, in case of WPF, as we know, in WPF you will find out WPF window, which is ultimately going to be a XAML kind of a rendered or written as in XAML. So you'll find out XAML resources out of XAML, which we are going to yet to talk about. So XAML resources are going to get compiled into something called as BAML, and BAML is going to be part of your WPF assembly in the resources section. And then whatever C# code, whether it is automatically written or whether it is developer written, you'll find out the partial classes are going to get compiled or clubbed as single class, then finally will be compiled into MSIL and will be represented into MSIL section. So you will find out WPF compilation is a bit different compared to something called as WinForm application. However, something which is going to be a curious topic in WPF is going to be what exactly this BAML is and why exactly do we need BAML. So that is something which we will have answer about in a while. So hold on, we will understand what is BAML, what's the use of it, who loads and understands the BAML, and is it something that what you see is what you get, or what you write is what you get. You'll find out WPF is not something like what you write is what you get. It's always going to go and add on some sort of extra elements to represent the complex elements in the hierarchy. So, and that job is well played by BAML and WPF runtime. So we will try to understand this WPF element hierarchy in a while.